Good day, everyone. I'm glad to see you. And it's the second webinar, which is dedicated to polysomnography. And last time I described the different types of PSG tests. And now this webinar is dedicated to the practice polysomnography. But we start with the term. What's the polysomnography? Polysomnography is a recording of multiple physiological parameters relevant to sleep. A main purpose of polysomnography is to identify some factors which lead to sleep disturbances. Majority sleep laboratory followed by the American Academy of Sleep Medicine recommendations. And now equipment, our PSG system is complies with recommendations. So, in accordance with recommendations and accordance with this society, there are different types of PSG systems, and this classification you can see here. And in accordance with this classification, there are 4 types of PSG systems. And the first type, it is polysomnography for facility. It is the sleep system for facility-based and full attended polysomnography. And this system usually includes all channels for sleep analysis, for respiratory monitoring, and for leg movement. Usually, the polysomnography with help of this system is performed with video monitoring. Now, Neurosoft can offer different types of PSG system, which can be classified as type 1 system, and it is a Neuron-Spectrum-4P, Neuron-Spectrum-5, Neuron-Spectrum-AM, and Neuron-Spectrum ambulatory monitoring, and Neuron-Spectrum-65. So, in accordance with this classification, we have type 2 sleep system, and usually this system, it is a portable system. Sometimes this system is called as the home sleep apnea testing devices. Oh, sorry. It is ambulatory system, and this system includes all channel for sleep staging, all channel for respiratory monitoring, and for movement analysis. The main features of this system that we can perform all full PSG test, but at patient's home at ambulatory settings. This test can be performed with video monitoring or without video monitoring. And now Neurosoft company can offer you one system which is classified as a type 2 sleep system. It is Neuron-Spectrum-AM. And the third time sleep system in accordance with this classification, and this type is called home sleep apnea testing devices, and it is a portable system, and usually this system includes the respiratory channels for respiratory monitoring only. And with help of this system we can perform the test which is need to identify the obstructive apnea syndrome. And now Neurosoft can offer the modification of Neuron-Spectrum-AM system, which is called Neuron-Spectrum-AM CRM, Neuron-Spectrum cardiorespiratory monitoring. And this system, it is specially designed for the home sleep apnea testing. And now on our website, on the neuronspectrum.com, they can see the Neurosoft solution for polysomnography. And our solutions in this solution is based on the classification which I've described. So now Neurosoft can offer you the 2 systems which could be classified as type 1 system. It is Neuron-Spectrum-65 and Neuron-Spectrum-AM. This system is used for attended facility-based polysomnography. It means that we can use this system at sleep center and this system and during the test, with help of this system, the medical staff monitor the patient, observe the patient during the test. Usually the video monitoring is performed synchronously with the PSG test. So now type 1 system, it is Neuron-Spectrum-65 and Neuron-Spectrum-AM, Neuron-Spectrum ambulatory monitoring. And we can offer the type 2 sleep system, and it is Neuron-Spectrum-AM. And Neuron-Spectrum-AM we can use for ambulatory monitoring. So with help of this system, we can perform the full overnight PSG test at the patient home. And the third solution of PSG of Neurosoft company, it is a Neuron-Spectrum-AM in modification of Neuron-Spectrum-AM CRM, Neuron-Spectrum cardiorespiratory monitoring. And this is modification is designed for the cardiorespiratory monitoring only. So it means if our users buy system Neuron-Spectrum-AM CRM, they have their special low price for this system. They have special delivery set, which include the electrodes and channel for respiratory monitoring only. And they get the Neuron-Spectrum software with the respiratory analysis module only. It means that the users who buy the Neuron-Spectrum-AM CRM, they can't perform their sleep analysis. If the users buy the system as type 1 or type 2 system, if they buy Neuron-Spectrum-AM as type 1 and type 2 system, of course, they can perform all tests. They can perform attended polysomnography, they can perform the ambulatory polysomnography and cardiorespiratory monitoring too. So now this is our solution for polysomnography. And so I've said that our webinar is a practice webinar, and we are going to perform the routine test, PSG test. And you know that to perform this test, we need to put a lot of electrodes and sensors on the patients. And I have put this electrode on the patient, and this is our patient. Anton, please. Anton, he is our engineer, and now he would be our patient during this test. He's the hardware developer, and he now is developed our new system, which we can classify as type 4 systems, Neurolex. And she agreed to help us with our test. So I have put all electrodes and sensors, and I divided all electrodes and sensors for polysomnography into 3 groups. First, electrodes. This is electrodes which are needed for sleep analysis, for sleep staging. And they are, in accordance to the American Academy recommendation, we need the following channels for sleep staging, which is electroencephalography, electrocardiography, and electromyography. So, in accordance with this recommendation, we need 3 EEG channels, and these channels are F4M1, C4M1, O2M1. So this 3 duration is enough to sleep staging. And in this case, we use reference which we put on the left mastoid. But, so if you can see, I put 6 EEG duration. So we have, I put the duration which I described, and I put the backup electrodes. So this is F3, F4, C3, C4, and we have an occipitals, 2 occipitals electrodes. Why we need 6 duration if there's 3 duration, EEG duration are enough for sleep staging? We put backup electrodes to, in the case if the main electrode fails, malfunctions. because it's very important to have information from frontal, central, and occipital area. And if some electrode from this area fails, we don't get information which is necessary for sleep staging. So we should to put 6 EEG duration, 3 main EEG duration, and the cap duration. So electroencephalography. For electroencephalography, we use we recommended to use cup electrodes with the electrode paste, and there are different ways to fixation of these electrodes. It could be a paste, 10-20 paste. It could be a medical tape or collodium, as you like. So it's very important to put on the patient the ground electrode, and here I put the ground electron. It's green wires. Next, duration which are very important, it is electroocculography. So we need to have 2 EOG durations, and the position of active electrodes follow. So the first active electrode, I put them 1 centimeter above and 1 centimeter lateral of the outer contours of the left eyes here. And the our electrode, I put 1 centimeter below and 1 centimeter lateral of the left outer contours. So we have 2 active electrodes. It is a reference electrode, and the reference electrode we put on the right mastoid. So so now we have a 6 EEG duration. We put 2 EOG duration, and the last channels for sleep staging is electromyography. So we ask the Anton take off the mask. Oh, sorry, I will help you. And so we can see the electromyography, the electrodes which were put on the chin. So in accordance with American Academy of Sleep Medicine recommendation, we need 1 EEG duration for sleep staging. We use the bipolar durations, but we fix 3 electrodes. And the third electrode we need if the main electrodes malfunctions. And so we put this electrode just in case, as we do it for the EEG. So the first electrode we put 1 centimeter above of the interior edge of the mandible at the midline. So this is electrode above the mandible. And the 2 electrodes we put, with 2 electrodes we put 2 centimeter below the inferior edge of the mandible, and 1 electrode 2 centimeter left, and our electrode 2 centimeter right from the midline. So we have 3 electrodes, and so which allows us to create a 3 bipolar duration. But for sleep staging, we need 1 duration, and in accordance with this classification of these the durations which consist from the electrodes which put above the mandible and below the mandible. So, 3 different signals we need. It's electroencephalography, electroocculography, electromyography for sleep staging. Now a group of channels which are very important to respiratory monitoring. And so we put the mask. So the first duration, which is very important, it is airflow. Airflow, and we have 2 different sensors which we can use for airflow measuring. It could be a thermistor, or it could be a pressure transducer with cannula. So in accordance with this recommendation, the thermistor is recommended for apnea detection, and then cannula or a pressure transducer sensor is recommended for hypopnea detection. And so we put two sensors on the patient's face. But in some cases, we can use one sensor. We can use over thermistor or the cannula. And in this case, this one sensor would be used for the detection of the apnea and hypopnea events. So this is first very main channels for respiratory monitoring. The next one, it is snow sensors here. We put the snow sensor, but we can, this is sensor to put the place on the skin. We need to ask our patient to imitate the snow. And we found on the skin the place where the vibration is the most. And they put this sensor and they screw this sensor with the medical tape. But we can register the snoring with help of the cannula too. So next, during the respiratory monitoring, we measure the chest and abdominal effort, the breathing effort. And to do it, we put on the patients the, so we put on the patient the two belts, thorax belt and abdominal belt. And in this case, we use respiratory inductive plethysmography. We use a rib belt, respiratory inductive plethysmography, rib belts with the sensors. So, but we can use the other belts with another sensors. We will show you later. So, very important to have body position sensors. We fix this sensor on one of the belts, and we put the pressure transducer sensor, and we put this sensor on the belt, on the respiratory belt too. So, next channel, which is we used for respiratory monitoring, it is electrocardiography channel, and one modified ECG channel with the torus electrode placement are recommended. And this is a bipolar duration. And the first, the negative electrode, we put, below the clavicular at the mid-clavicular line here. And we can use different type of electrodes. We can use the single-use electrode, as in this case, or we can use a reusable cap electrode for it. This is first electrodes, and we use the bipolar electrode. It is one electrode, and another electrode we put at below chest, and in the 6-7 intercostal space at the anterior axillary line. So we have two ECG electrodes here and here. Last electrodes, which we don't put on our patient. It is a pulse oximeter sensor, and we put this sensor when we start our test. So we will be used the Neuron-Spectrum-65 system during our test, and this is a system connect to the computer with a cable, and so all what is done, we need to use a patient unit when we use the Neuron-Spectrum-65 systems. With patient unit allows the patient to connect or to disconnect from our system. Now you see that we put all electrodes and sensor, but now he disconnect from our system, and he's free to move. So I think we are ready. We are ready to start our test. So So we, oh, sorry, I forget about EMG electrodes. And please sit. So we need two bipolar EMG electrodes, which we put on the patient leg. And so we try to show you. So with one channel, this is another channel. They put the electrodes on the anterior tibialis muscles at the middle part, and with distance of 2-5 centimeters, and to record with signal could be used reusable or disposable electrodes. Of course, with cable from these electrodes, we connect to the patient unit. So now I've described all electrodes and sensors, and we can ask our patient to lie down and relax. So I hope you. So we need. So we need to connect our patient unit to our system, and here we have a cable. Oh. So we connect to a system. And now we can start our test. Are you comfortable? It's okay?
Yes.
So we need some time to show you our software. And so we use Neuron-Spectrum.net software, and this software can be used for polysomnography analysis. And now we start new study, and we start with the patient information. We should type all information which we need, and this information goes to the report at the end of the our test. And so I enter the patient's name, and if we now his height and weight. So our report, the body mass index will be calculated. So I check up the montage which I need, and okay. In Neuron-Spectrum software, include the different type of preset montages. And we will be using the montage which is created for Neuron-Spectrum-65 system, for this system which we use. Of course, it's very, very convenient if we have two monitors. And I like this variant of the PhD test when on the one monitor we see the traces, and the monitor is needed for the video or for trends and for tapes, but it's very good if we have two monitors, and our system allows to do it. And so the video is recommended during this test, and we can connect to our system till 3 camera, and now we have 2. We can change the positions of the camera here. So that's okay, and we are ready to start. So of course, it's very important to check out the impedance, because the quality of our recording depends on it. So So that's okay. All the impedances are rather low, and we can start our recording. So, as I said, they can create 3 EMG channel, but in majority case we use only 1. So some duration we can hide. That's okay. So we can start with the monitoring. We ask our patient relax, and yes, I said that we need to put on the patient SpO2 sensor. So now in this case, we use the Nanin sensor. So we put this sensor on the patient. And what we see here. So this is electroencephalography. They ask our patient close the eyes. So this is EEG channels, this frontal, central, occipital area. That's okay. And this is a chin. From them, this is the electromyography from the chin. This is electrooculography. So here, this is a snoring sensor. Oh, we can change the amplitude. And this is ECG. ECG has a very large amplitude. So the thermostat. This is a cannula transducer sensor. This is a respiratory effort. It's not very good, so it's just a look here and here. So we have seen the breathing wave. This is a SpO2 sensor, a SpO2 signal. And this is body positions, leg movement. So when we start our study, we need to start with them with the biocalibration. And the biocalibration is very important to document the appropriate signals during the test. And this biocalibration consists of several maneuvers, which we try to show you. And first, we need to record the 30 seconds of EEG when patient lie down and the patient open his eyes. So we ask our patient to open his eyes, and we can put the marker here. And so we see that we have an algorithm, and when the patients open his eyes, the algorithm is blocked, and we can see the death rate, so that's enough. Now we ask our patient to close his eyes, and we and relax. So it's very important to have algorithm. We see that this patient has algorithm, but he's not relaxed, I think. Yeah, here we have a little algorithm over here, so maybe we will get a high amplitude algorithm. And to please relax, not to open the eyes. Okay, so we have some algorithm here. It's not very high amplitude, but I think then he fall asleep, he has a high amplitude alpha rhythm. Oh, here we have alpha rhythm. So that's okay. And now I ask our patient to look up and down. Anton, please look up and down without head movement. So now we can see the eyes movement here. It is the eyes movement artifact on EEG. That's okay, thank you. So now I ask our patient look left and right. So we see the eyes movement too, very high amplitude. Okay. Thank you. And now, so we can see that we have the eyes movement. Anton, please close your eyes. So we can see that the patient, so we see the eyes movement is out phase deflection on electroculography. It's very good. And now we ask our patient to blink. Anton, blink, please. No, поморгай, пожалуйста. So thank you. So it's not very high amplitude. Please to blink again. So here we can see the blink. Okay. So here's they see the blink. This is thank you. Close the eyes. This is in phase deflection here. Now we ask our patient to grit the teeth. So, chin here. Again, please, Anton. Попробуй сжать, пожалуйста. So here we can see some EMG artifact, the increasing of EMG amplitude, and you can see EMG artifact on EEG. So relax, please. And when the patient relaxes, the amplitude of EMG signal decrease. Very good. So here we can see the ECG artifact on EEG. Okay, and now we ask our patient to simulate the snow. Похрапи, пожалуйста. Еще раз. It's not very high amplitude, so try again. Еще раз. Here, so we can see the some. Here, there are some snoring event. Here, very good events. So we can see that our system allows us to identify the snow events here. Okay, now thank you. And now we ask our patient to hold the breath. Anton. So here we see a wave, and now we can see the only line without wave. Thank you, Anton. You can continue to breathe. So we can see there. Sorry? So we just a little. So Alexey said that we should to have all the all the channels, breathing channels, synchronously, and you can see that the precious line, it is asynchronous. So, and I'll check it. Maybe I connect with channel wrong. No. It's okay, exactly. So we can check it. So And now we have a look. We can look. Антон, please, can you breathe deeply? Глубоко, подыши, пожалуйста. Вдох. So now we can see that all our channels are synchronous. Okay, very good. So we can change the amplitude of our signals. So our next maneuvers is we should ask our patient to raise their left toes. So we can see this is EMG from the left toes, from the left foot, from the left leg, and they can see very high amplitude. Thank you. High amplitude or events. So now we ask our patient to raise their toe of their right foot. Okay, very good. So very, very high amplitude. Thank you. And so I didn't. And okay, and now we ask the patient to repeat these maneuvers with both foot. So we have a bipolar EMG event. So now we perform the biocalibration. It is very important to understand that our system works well. So, and now we can start our routine test. And I recommended to press on the light off. It means that here is a start of our study of our test, and all our detectors and all our algorithm would be worked from this moment. Then they put these markers, and if they don't put these markers, so all detectors will be work from the beginning of the test. So we ask our patient, close his eyes, relax. And honestly, our patient did not have some sleep disturbances, but we ask him sometimes to hold the breath. And we'd like to see how the apnea events looks like. Anton, okay? So, and then our when our polysomnography study is being recorded, I'd like to show you in our system, which is our polysomnographic system 2. It is a Neuron-Spectrum-AM. Neuron-Spectrum-AM, it is a portable system which includes all channel for sleep analysis, for respiratory analysis, and for movement analysis. And it means that with help of this system, we can perform attendant facility-based polysomnography as we do it now, that we are doing now. So and the great advantages of this system is that it is a portable system. It means that all electrode and sensors we connect to the unit, to device, and put on the patient with device with have special belt. And our patient, of course, is free to move. And now in our case, we have a patient unit which is connected with the cable to the system. When we use the Neuron-Spectrum-AM movement, we does not have this cable. So it's a very great advantage of this system. And we can perform the video monitoring with the PSG recording. So it would be a routine PSG test as we are doing now. So Neuron-Spectrum-AM, it is type 1 sleep system. But as I said, the routine test, which is the gold standard for diagnostics of sleep disturbances. But in some cases, we can suspect that our patient has obstructive sleep apnea. So obstructive sleep apnea syndrome is characterized by the loud snore, the severe daytime sleepiness. These patients sleep everywhere we want to sleep. And with obstructive sleep apnea, it's characterized by them. We called it witnessed breathing disturbances. It means that the bed pattern of the patient see their pauses on his breath during sleep. So the bed partners see their apnea during the sleep. And very often these patients suffer from obesity. And in this case, the sleep specialist can think that this patient has obstructive sleep apnea syndrome. So, and he can recommend him to perform the cardiorespiratory monitoring. So during the cardiorespiratory monitoring, we analyze the respiratory events only, and with this test is recommended for patients with high pre-test probability of obstructive sleep apnea. So, as I said, that we can offer our users Neuron-Spectrum-AM as cardiorespiratory monitoring, and in this case, they get the delivery set. So I'd like you to show how our patient looks like when we put electrodes, a sensor for cardiorespiratory monitoring. So this is Alexey, he is our EEG product manager and agreed to help us. And if we compare our patients, the Alexey and Anton, so you see that it is this is easier test because they have a few channels for cardiorespiratory monitoring. So we can use cannula in this case, but we can use a thermostat. We use respiratory belt for detection of respiratory effort. So in this case, we can use one belt. And we use SpO2 sensor pulse oximeter. And please look that in this case, we can offer our user disposable SpO2 sensor. And when we perform reusable sensor, I put on our patient. And I remind you that we like to have a whole breathing. Yes. Okay. So our patients, all electrodes and sensor, we connect to the with unit. So, and this test very often can be performed at patient's home. And in this case, we call a cardiorespiratory monitoring. Oh, thank you. So, Neuron-Spectrum-AM can be a sleep system, type 1 sleep system, and they perform ambulatory monitoring with help of, and they perform the routine test in some sleep center. This system can be used as ambulatory monitoring, as cardiorespiratory monitoring. We can use it for cardiorespiratory monitoring in patients' home at the ambulatory, at the patient's settings. And I think that it is the best solution for this system, that we can use this system as ambulatory monitoring. And we can perform the full PhD test, overnight PhD test, as we do it in this moment, but we can perform this test in patient home. And so it means that we put on the patient electrodes for EEG, EOG, EMG for sleep staging. We put on the patient own electrodes for respiratory monitoring, and we put on the patient the EEG electrodes. and the patients stay at home, and we perform the routine test, which is we know that it is the golden standard for diagnostic sleep disturbances. We can perform this test. We can perform this ambulatory test with video recording and without video recording. So, and in accordance with the American Academy of Sleep recommendation, now video monitoring is recommended for sleep study. Of course, they know that the advantage of ambulatory monitoring is clear. It is the reduce the cost of the test. It is enhance the patient satisfaction. Of course, it's more comfortable to stay at home during when we perform this routine test. And this ambulatory PSG test, it is the ideal solution for the person who is disabled, the person who have persons who have children and some significant family commitment. And I think that some technical aspects of the ambulatory monitoring with help of Neuron-Spectrum-AM would be described by our product video EEG product manager, Alexey Ivanov. So Alexey, please.
Hello, dear colleagues. I hope you can hear me. Yeah, thank you. Hello, dear colleagues. My name is Alexey Ivanov. I'm a product manager of video EEG, Neurosoft devices, and I'm a service engineer as well. So let me describe a couple of things about technical aspects of using Neuron-Spectrum-AM in ambulatory mode. Just give me Tatyana, may I ask you to take me the device itself? Thank you. So this little box, as Tatyana said, it can be used as PSG full size PSG device, as well as cardiorespiratory monitor without any EEG channels and so on. There are a couple of things you need to know about this device. It can work via as a standalone registrator in case of Alexey. In case of Alexey's case, it is recording data on the memory card continuously. But there is other way how to use this device. It can be connected via Wi-Fi to the laptop or to some, to the PC via wireless network, and it can transmit data in real time to the computer, and so you'll be able to see all the signals in real time. Also, you can connect a video camera to this network, and you'll be able to record PSG signal with video signal, and as well as data from the sensors and derivations. Ambulatory monitoring, especially out of the hospital to the patients' houses became popular, especially in the United States and on Europe, especially for private medical centers. They're able to take device at patient's home, take the laptop, small video camera, like let me show you. Like this one, right on the table. It is a small portable heat vision camera. It can transmit video image via Wi-Fi, and this video stream can be captured by Neuron-Spectrum, Neuron-Spectrum.net software. And so you at the end you'll get video stream from the camera synchronized with the data from with the signals from the device. It is the way how to organize portable, portable set of the devices in order to record PSG examinations at patient's home. It is, by the way, it is good practice because some patients are not able to sleep out of their houses. For example, if we put the patients with sleep disorders into the hospital, most likely he wouldn't be able to sleep because of because of environment is not native for this patient. That is why it is suitable enough for patients to have an opportunity to record such type of examination at their home. So it is about the portable set. Of course, if you have a special room in the hospital for recording during the night, for sleep recording, so you are able to mount the fixed camera with PTZ, with zoom, and connected by wire to the local network, mount access Wi-Fi access point in the same room as the patient, and the patient in this case, in the case of this device, patient will be free to move around around the room. For example, he can do some things. For example, he'll be able to go to the toilet with the device. So it is not necessary for him or her to disconnect themselves from the device. So the record is still continuing even when patient go, even the patient go. I think that is all what I had to say. That is all that I wanted to say. So, as a conclusion, I would like to say that you have 2, 3, or 4 and more possibilities to apply our devices, to use our devices, depending on your goals. So we'll be glad to help you. The service center of the Neurosoft company, as well as product management, Tatyana and Alexey, will be happy to help you improving your experience of using our devices. So thank you for the attention. Tatyana will continue our lesson. Just a minute, please. I will reconnect the cameras.
Alexey, thank you. And I think that the ambulatory PhD is a very important part of it's an important way of polysomnography development now. But now we start our new part, which is titration PhD study. Last time we described the PhD with titration PAP device. And so I start that, that is PAP. And now the positive airway pressure, it is the main therapy for patients with obstructive sleep apnea. And to perform this therapy, we need PAP device, and PAP device with this system consists of several components, and this is device. This is device, PAP device. This is mask which we put on the patient's face, and there are different types of the mask, and this is full face mask, and there's a very, very little mask known, and we connect this mask to our unit with help of this flexible hose. So here. And this device, this is a pump which create under the upper airway the positive pressure for maintaining the upper airway latency. It means that the obstruction of upper airway, it is the main causes of obstructive sleep apnea syndrome, and this system prevent these obstructions. So, and this is the main way of therapy this patient, one of the way. But there are different types of with devices, with systems, and the auto-titration CPAP devices, auto-titration PAP devices exist, and in this way, sometimes the patient, the medical specialist can recommend to use the auto-titration devices and auto-PAP devices, but in some cases, especially then that person has some comorbidity, we need to perform titration, PAP titration test in laboratory, and we perform manual titration PhD test. And so what we are doing during this test, that is the problem why we need to perform this test. The problem is that the value of the pressure which prevent the obstruction of upper airway is different in different patients. So, so the effective pressure which prevent the obstruction is different. This value could be different. So some patient has effective pressure 5 centimeter H2O. Other patient has their effective pressure 10 centimeter H2O. And very important to find this effective pressure value. It's one hand. So one hand we need to have effective pressure. On the other hand, we need to have a minimum value of effective pressure. Why? If our value of our pressure would be very high, our patient does not fall asleep. So they're very important to get the minimum effective pressure, the minimum value which prevent of obstruction. So if our patient use their outer tetration devices, so these devices can adjust this pressure automatically, and we need to perform the titration test in the lab. But if this patient does not use these devices, so we need to perform this test in the patient laboratory. And we need to transfer information from the device, PAP devices, to our system. Last time I described several ways how we can transfer information from the PAP devices to our system. And now I'm going to show you several ways of it. So I've said that the first way how we can perform this test, and we can put the pressure value on our software manually, and we use the pressure markers for it. But we should to put the mask on our patient. It is our first that we need to do. So I think I stop our recording, and we will show this recording in some seconds. And we wake our patient, ask him. So we ask him to take off the mask because we put on his face our mask. So look here, this mask has a port. Here's a port, and I connect to this port with tube, and with help of this tube, we can measure the pressure, the patient airflow. I connect with tube to our pressure transducer sensor. So now I take off the cannula and put on the patient mask and connect with tube to the cannula. And in majority case, I think almost always, we take out the thermostat sensors too, but sometimes we can not to do it. So we can perform with test with thermostat sensor under the mask. So in majority case, the one airflow channel is enough to perform titration test. But now we don't take the thermostat sensor off from the patient. So I connect this mask to the PAP system with this flexible hose. Now I take out the cannula. So, and look here, the thermostat sensor on the patients now. And I think it's not very comfortable. We try to show you that we can do it. And now we put on the patient this mask. So that's okay?
Yes, all right.
So we should to fix this mask. So I put it here. it's very, very important to have the mask of several sizes to find the mask which would be very comfortable for the patient. That's okay?
Yeah.
So I connect the tube to the pressure sensor. So now we ask our patient, lie down. So. That's okay? Okay. So before we start the titration test, I share my computer and oh, something happened. Dixie, can you help me?
Sure.
I don't find it. Oh, okay. Thank you. It's a great engineer, which he's ready to help me and you, I think. So this is our routine test. We can look it. Alexey will describe in detail, but we have different algorithm which we can use for detection. So we have a list of this algorithm, and now we can perform, for example, respiratory event detection algorithm. And I did not add the trends. So here we can see there's some apnea event, and I think it would be ladder. So here, so we can conclude that our patient here, that our patient has obstructive sleep apnea and he needs to see PAP therapy. So now we need, it's very important for us to find the pressure value which is would be effective for this treatment. So here we can special setting PAP CPAP pressure manual input, and we will be used this function in software. So we should to start then our new part of the test. So we and we can start recording. So first of all, that we should to do, we should to start the work of our PAP device. So I have a PAP device, and now I should to start our test. Anton, please close your eyes. So we start with the minimum pressure value. It would be 4 centimeter. So we mark here CPAP pressure manual, and here I type 4 centimeter H2O here. And in this moment, we can see that markers, which has a name 4 centimeter H2O, and it would be very good if we add the trend list, one trend. We have a lot of trends which we can use, but in this case, we will use the CPAP pressure trend. So here, okay. So, as I said, it's very good if we have to monitor. Okay, but we can change the height of the trends list here. And now we can see the trends. This is our routine part of the test. Then we don't have some pressure. So this is the test without the therapy. And now we start the titration test, and on the trend we can see the level, which is 4 centimeter, which is marked 4 centimeter. And now we ask our patient hold their breath. So here. So, and they can see on our channels that this patient has pauses during his test. So we're waiting for 10 seconds because the minimum duration apnea or hypopnea event, which is 10 seconds. And so, okay, thank you, Anton. So we have events, and in this case we can increase the pressure value because the 4 centimeter of pressure is not effective for this patient. I don't want to describe the titration procedure. There is some recommendation for a titration test, which is published by American Academy of Sleep Medicine. And in accordance with recommendation, we need to have 5 events and we in some positions. But my task is to show how we can perform this test with help of our equipment. So we think that we have 5 apnea events, and now we can increase the pressure. So we should increase this pressure on our pump device. Okay, and we should type this level pressure. So now we type the 5 centimeter. Okay. Now we can see the new markers, 5 centimeter, H2O, and in some seconds we will see it on the trends. And now look here, we have, this is respiratory, this is electroencephalographic channel, EEG channels, this is electromyography channels. Here we have some, I think the ECG artifact here, but we can use the other EMG channel from the chin. This is electroocculography. This is a snow events, and this is ECG, and this is respiratory channels, and thermal sensor, as I described, the put on the patient during this test, and this is a pressure sensors. This is a pressure channels, and we measure with airflow with help of a tube which I show you, and this is a force sensor. So now we ask our patient to make a breathing pauses. Okay, and Anton, please.
What I will do?
Please stop breathing. Hold the breath. So we can see that the patient stop breathing, and our pressure is not effective now, and we can input there in our manual pressure, and for example it could be 6 centimeter. Okay, and now we can see the pressure markers, which is marked there 6 centimeter H2O, and we refresh our trends. So this part was then the pressure was 4 centimeter. This part then the pressure is 5 centimeter. So now we can perform the respiratory event detection, and you can see that during this pressure, our patient has some events, apnea events here and here. So, and it's help us to determine that our patient has some breathing disturbances during the test, and this pressure is not effective. So now we can ask the patient hold the breath again. Anton, please hold the breath. So, and we are waiting for 10 seconds. Thank you, Anton. We have some central apnea now. And it means that our pressure is not effective, and we increase the value. It was so CPAP manual, and we can increase and input the 7 centimeters. Okay. So we repeat this procedure until our patient. When during this pressure, our patient does not have apnea or hypopnea events. So this CPAP during this test, we can input with such markers the information from the CPAP. It could be, for example, leaks, for example. We can input the leakage during this test, and now it is 12 liter, and this information would be on our PSG test. So now we see we can perform the sleep staging and during this test. And unfortunately, yes, our detector is right. Our patient is awake, but we have changed this stage because our detector, because we calculate apnea and hypopnea events during sleep, and I will do it in some seconds. And now we can see that our patient does not have some breathing holds. It means that the 7 centimeter of H2O, so we can switch off our CPAP, and that means that the 7 centimeter of H2O is an effective pressure for our patients. So, and they can, of course, we need to record some time, but now we can stop. So here, now, yes, okay. And so in this variant test, which we perform, we can call it a split night test. So I will change the some sleep staging. Because it is need to pay to our system calculate apnea hypopnea indexes during this test. So I change it. Okay. And very important to have some sleep stage during the pressure. So, okay. So, as I said, our test, we can call the routine, or we can call split night test. And some part of our test, it was a routine PSG test, and we does not use the PAP titration. But this test, this part of the split night test is usually 2 or 3 hours, and then the medical staff see that the patient has a lot of obstructive events. He can wake up the patient as we have done, wake up him, put the mask, and perform the titration during the PSG during the last part of the night. So it would be split night. split night test. Now we can calculate some parameters which are needed, and now we have okay, different part of this test. So we have diagnostic part when they did not have their pressure during the test, and therapy part. Here's the therapy and diagnostic part, and this is parameters for whole period of PhD test. And here we calculate them some parameters as the total sleep time, the total true time, and some latency, number of awakening and sleep efficacy tests, sleep efficacy indexes during diagnostic part of the study and during therapy of the part of this during therapy, and we can compare this result. So as I said, diagnostic part, it is part when the pressure of PAP was absent, and the therapy, it is part then we adjust the pressure of PAP system. Now we can see other, for example, sleep staging. For sleep staging, we have this such different part, diagnostic part and therapeutic part, and we can compare some information from diagnostic and therapy part of our study, and they can assess the efficacy of our therapy. And of course, we have special tapes, respiratory tapes, and here very important for us, it is some PAP statistics, which include the different parameters during the different level of PAP pressure. And of course, they can find the main effective pressure for our patient. And of course, here we can see the number of some respiratory events and the indexes with events during sleep. And so we have such indexes, the apnea-hypopnea indexes during the different pressure level here. So now we can create our PhD report. So we can select the special PhD report here, and okay, polysomnography. This report will be created in accordance of the template which we create before our test, but all part of this test we can change. So we have these sleep statistics, which I show you. This is a hypnogram. This is a PhD events during our test, SpO2, trends, EMG. Here we can see the body position and sleep stages, some characteristic of different stage of rapid eye movement sleep and non-rapid eye movement. We have some graphs. Of course, we can add some information. For example, from our test, I like to add a Ruiz table. We can copy these tapes to the report. So we can see here then our report. And of course, we can type some information here. Conclusion, and we can print this report. So, and very important to save our exam. So it was the first type, how we can transfer information from the CPAP to our software, and we use to do it, we use the manual placement of markers. But we have another way. So some, oh, sorry. So sometimes the majority, I think that majority of PAP device manufacturers, they produce another module. This is a module we sometimes called as PSG module. It's maybe polysomnographic unit, different names. So, and we have soft model here. Oh, so I'm not sure. So this module has different output here, and in our case, this output are marked as a pressure, flow, and leakage, and we can connect with output to our system to DC channels of our system. So in our way, we can use this, in our way of transfer information from the PAP to our PhD system. It is the application of this special model. But we can connect with model for DC channels only. And for example, if the first variant of the PAP titration, which I have shown you, we can perform using different types of our system. We can use the Neuron-Spectrum-AM, Neuron-Spectrum-5, or Neuron-Spectrum-65. But when we but if we'd like to use such module, we need a system which includes several DC channels, and in our case, it is Neuron-Spectrum-65. So it means that we can't use the Neuron-Spectrum-AM for this when we use this module. So this is some limitation of the Neuron-Spectrum-AM system. But now we will use this system. So, and I'd like to show you. So we can start with another titration. And I now should share my computer. So if in first part, in the titration study, we use a split night, and now we can use the two different tests. So we can imagine that we have a diagnostic study, and we know that our patient have obstructive sleep apnea, and now we perform the new night, the second night, and now we perform titration study with help of these devices. So, and now, very important for us to choose another the montage. I have created this montage before, and okay. So now we can start our acquisitions. So please have a look. We have the same channels, and now it is the same channels, and now we have two new channels. The first channel is called flow PAP, and the second channel is called PAP pressure. So this is two channels. So they are marked with DC1, DC2. It means that with information we get from these channels, and it means that our PSG module is connected to these two DC channels. And here we get information from the CPAP. So it means that we will have three airflow channels. The first one, airflow channels, it is the thermostat. which we put on the patient under the mask. This is the pressure channels, and we measure the pressure airflow with help of the special tube. And this is the flow which we'll get from our PAP devices. But before we start our titration, it's very important to us to perform calibration of PAP system. And so to perform this calibration of PAP pressure sensor, we need to use this instruction. So here, automatic DC sensor calibration. And now we should to set PAP pressure value to 4 centimeter. I've done it. And press OK. Okay, that's very good. The impedance. And now we perform the calibration. So after that, then the messenger pair, and now we should to set the pressure value to 10 centimeter. So I've done, okay. Very often we need to do this calibration one time, or in some cases when we have some doubt about that we have doubt about the pressure which we'll get from our system. So he's okay, yes. So now we are ready to start our test. So I change the pressure, I decrease the pressure level. So we can start recording. So now we can see that the PAP pressure is 5 centimeter. Here we can see the flow. Something happened. Oh, that's okay. So this is a thermostat airflow. This is the cannula airflow. And what's up with our breathing? It's not very good. Anton, please breathe deeply. Anton. Okay. So we should adjust the abdomen belt. So here. Okay, here. So this is effort from the thorax and the abdominal belt. So, and we can add the pressure trend during our test. Okay, as we done it, and here I add the pressure trend, PAP pressure trend, and I decrease the height of the trends. So here we can see the trends of 5 centimeter here. And this information we get from the, with help of this PSG unit. Now I can, Anton, please hold the breath. So, and we can see this line. We can see the pauses during their breathing on the thermal channels on the pressure channels and on the flow PAP channels. Okay, thank you, Anton. And now we'll get the normal breath. So, but this we suppose that during breathing means that our therapy is not effective. So we should increase the level, pressure level. So I've done it. And so we need some time. So we can see that now our pressure is 7 centimeter. And the trends of pulse pressure is refreshed too. And now we ask our patient hold the breath again. So, and now we can, thank you, Anton. And now we can increase the pressure value again. So, okay, 1 centimeter. So they can see that the new pressure, 8 centimeter here. And so if this pressure would be ineffective too, of course, so we will increase this pressure value till where some respiratory event disappear from the polysomnography. So I think it is clear how we perform this test after that, and they can stop our test. We can stop our test, and I switch off the pressure, switch off the pulse devices. So this is the second way how we can transfer information from the pulse machine to our software, and we can create the sleep staging. No, it is awake. I need to change with stage. Okay. Okay. And I need to perform automatically pulse markers placement, and we can see some with parameters in accordance with new pressure, pulse pressure. So here we can see the sleep statistics. And I think they're more interesting for us. It is respiratory analysis during sleep. And here we have some different analysis, some events. Oh, we don't perform this test. We don't find this. Okay, we will perform with detectors, so respiratory event detectors. So we need several events, and now we will see the respiratory analysis during sleep. And so we can see that with respiratory events goes to our tapes, and now we can create the PSG report as we have done it before. So this is the second way how we can transfer information from the pulse device to our systems. And I think that the EEG product manager, Alexey Ivanov, is ready to describe us another way how we can work with the pulse devices, and he gonna to describe some settings of Neuron-Spectrum software.
Thank you, Tatyana. Please, can you close your screen demonstration? I will open mine. And now I'll just briefly show you how we can analyze a polysomnographic examination. I am opening already a recorded PSG exam. Here it is. You can see native PSG traces. You can see already a scored hypnogram. We can see sleep statistics window and a video window. So what we can do? First of all, we can review PSG traces with mouse wheel, with keys of your keyboard, with special buttons on toolbar. Also, we can navigate via traces using hypnogram window or we can open trends, for example, PSG event trend. Here already all PSG events already are marked automatically, but we can do it also manually. We can change duration and location of each episode. We can mark episodes manually like this. We can select the type of episode. As for hypnogram marking, we also can mark it manually or in automatic mode. For example, I'll create new hypnogram. Now it is empty. I goes to the start of the examination, and using these toolbar buttons, I can start hypnogram scoring one by one, like this. Or I can also use my keyboard keys with 1, 2, 3, 4 keys for scoring hypnogram. And also I can use arrow keys to move in with the same stage, like this. When hypnogram scoring is finished, I'll just switch to already prepared hypnogram. We will see results of analysis. In this window, we will see some sleep statistics. For example, recording start time, end time, when lights was on and off, how many time patient spent in bed, and so on. All these parameters are described in the user manual. And also using context menu, you can set up visibility of rows and columns of this table. For example, you can hide some not necessary parameters, and you can stay only parameters which your doctor prefer to see. Also here we can see some results of analysis by sleep stages. For example, we can see latency of each stage. We can see percent in total sleep period of time for each sleep stage, and we can make a decision in which sleep stage patient slept more time during night. Also using toolbar buttons, we can start automatic analysis of all kinds of signals. For example, automatic sleep staging, automatic arousals arrangement, and so on. Here also we can put lights on and lights off markers. We can put arousal marker. If we have no body position on our device, we can mark body position with these markers manually. And also we can mark CPAP events like Tatyana already showed you. But also I need to add that we have collaboration with BMC CPAP systems. It is a Chinese producer of CPAP devices. It's a very famous producer, and CPAP devices are quite good, with good quality and a low price. And if you use this CPAP, you can directly from our PSG software set commands for this CPAP. For example, to set CPAP pressure according to this CPAP pressure. And also you can use auto CPAP mode, and you can manage CPAP device directly from our PSG software. It is very convenient. Also on toolbar, we have a button for different analysis windows. I'll show you later. All kinds of analysis. Also, we can change the sweep speed of our traces. For example, for reviewing EEG, we can make visible only one epoch on screen, like this. Only 30 seconds on screen. In this sweep speed, we can clearly see EEG traces, for example, like this K complexes and spindles. But for example, it is not very clear to see breath disorders in this sweep speed. So we can change it and show, for example, 11 epochs on screen. And in this sweep speed, we can clearly see very nice obstructive apnea episodes. and arousals, episodes and desaturations, and all others. Also, we have a special tool for reviewing traces, for example, in separate mode for sleep analysis. In this mode, you will see only EEG, EOG, and EMG traces and body position also. And for example, in respiratory analysis, visibility, you will see only ECG and respiratory traces. And also we have the special mode for reviewing EEG traces in two different windows, like this. In top window, we can review EEG in sweep speed. For example, we can make it half of epochs, 15 seconds. And in the bottom window, we can see other traces. For these traces, we also can make separate sweep speed, for example, like this. This blue square shows us where is EEG located here. So we can see EEG part, EEG traces of this blue part of PSG traces. It is also sometimes a very convenient way to review EEG traces, like this. Also, we have the special mode for automatic trace scale. I'll show you, for example, like this. As you know, during PSG, amplitude of different signals can be quite different. It depends on quality of signals sensors placement, or it can depend on breath and amplitude, for example. And we always can, pressing this button, we always can change scales of each traces just for a better review on the screen. And also we can put manual markers for blood pressure. And if you use a BP lab device for blood pressure measuring, you can also send direct comments from our PSG software to this device for blood pressure measurement. That's all about these buttons. And now I'd like to show you the results of this PSG examination. For example, here it is quite typical for this patient picture, where we can see a lot of obstructive apnea events. You can see it. Between these events, we have several episodes of breathing. Patient wake up. Here we can see the arousal. Patient wake up, start breathing, then it goes back to dream and stop breathing. And this is repeat and repeat during all night. Also, you can see here desaturation episodes because of not enough oxygen in the blood. And for sure, we can see the snoring episodes and limb movement episodes after each episode of waking up. As I told you before, we can mark episodes manually, as I do now. For example, for limb movements, I can make it manually, or I can use it automatically using, for example, context menu of different type of traces like this, or I can use context menu on corresponding analysis window. What kind of analysis window do we have? For example, for this patient, it's interesting to see results of respiration analysis. On first page, we can see different kind of respiration episodes, and we can see, for example, index of each episode. And it is very clear to see that the index of all type of apneas is very high for these patients. It is 43 per hour, 43 episodes of apnea per hour. And maximum duration of apnea episode is almost 2 minutes. It means that 2 minutes patient not breath at all during night. Average duration is 43 seconds. Total number of apneas is 270. And total duration, just imagine the total duration of apneas episodes is more than 3 hours. And if you can see here, the total duration of PSG examination is 8 hours, and total sleep time is about 6 hours. It means then more than 50%, more than 51% of total sleep time, this patient didn't breathe at all. It is very dangerous situation for this patient, for sure, and it is necessary to use, for example, CPAP therapy for this patient. Also, I wanted to show you one more interesting detail for reviewing PSG traces. Here we can see ECG trace. It is here. And it is not very useful for us to review it in this case. It is more useful for us to review heart rate trace, not ECG. And we can do it using settings of this trace. We can check this checkbox, show pulse trace, and we also can put the borders for our heart rate, and we also can hide native ECG trace. It is not very informative for us in this sweep speed especially, and we can replace our ECG trace by our heart rate trace. And you also can see the results anytime when patients start breathing and wake up, the heart rate is growing up. You can see it very clear here. We can switch to another part of night, and the picture will be the same. You can see it is always the same. It means that heart of this patient is working in very dangerous conditions. It is low heart rate and then high heart rate when patient wake up. We can make some analysis of heart rate and look at more detailed, but for this patient I need to say that it is his heart in good condition. Minimum heart rate is 47. We can see it here. 47, yes, 47 beats per minute, and the maximum heart rate is 110. It is here, and the heart rate variability is 63, but number of bradycardias, tachycardias, and asystoles is both 0 for all these episodes. It means there are no tachycardias and bradycardias for this patient and no asystoles. It means that heart rate is quite constant for this patient, and we can see it in scattergram, for example. It is scattergram is quite good. It is healthy person according his heart rate. Also, if we have some blood pressure measuring, we will see results of measuring here, and we will see some graphics of duration of each head blood pressure position. What else is necessary to see? It is very important to review results of CPAP titration, as Tatyana showed us today. For example, here in this examination, we have several parts with CPAP titration. We start with 0 pressure, then we increase pressure with step of 2 centimeters, and we can see that when we set 12 centimeters, the index of apnea and hypopnea index, the index of these episodes become 0. With 10 centimeters, it's increased, but not enough. But with 12 centimeters, we can see that it is good result for this patient to use 12 centimeters of CPAP pressure for treatment of respiration disorders during sleep. As for arousals, we also have the special tab for arousals analysis, where we can see number of arousals during sleep. It's 184 arousals, and we can see that most of them are respiratory event related arousals, and only 43 limb movement related arousals. It means that most of arousals are related with breath episodes for this patient. And also, if we check the duration, index of arousal duration, index of arousal duration during sleep, we can check that it is 26%. It means that 26% of sleep, this patient was in awaked state. It means the quality of his sleep is not very good. You also can show these results to the patient to make him understand the quality of his sleep. Also, we have, for example, oxygen desaturation analysis results, where we can check results of oxygen saturation. Here we can see results of average oxygen saturation by epochs, and we can find very easy the epochs with very low oxygen saturation. For example, here I just ordered this column by from low to high, and with this column, I just move to the traces where it is such a desaturation located. You can see here that is very low saturation level. It's 56 saturation level here because of a lot of desaturation episodes here. And also in results of oxygen saturation analysis, we can see that total duration of selected oxygen desaturation events is more than 3.5 hours. It means that more than 50% of total sleep time, this patient was in a desaturation state. It is also very, very dangerous situation for this patient. And also, we have a lot of other type of analysis. For now, I have no time for describing all of them. I just wanted to show you results of this examination in a report. Here is the report where we can see passport section of our patient, then sleep statistic results, then our hypnogram, our trends, all trends included here, but we can choose what trends to include in our report template, body position and sleep stages analysis, statistics of sleep, and then respiratory events analysis in table and graphical view, oxygen saturation analysis, snoring analysis, and limb movement analysis in the end. As you know, we can set up our report templates and prepare very flexible reports for your customers. I think I have no time anymore to describe you analysis tools, and I should back to Tatyana and continue our webinar. Tatyana.
Thank you, Alexey. And it's very important to have a software which help us to describe, to analyze such complicated study as polysomnography, and our software really help to do this. And in conclusion of our webinar, I'd like to say that now the Neurosoft can offer our users different type of PSG system, which allow us to perform different types of polysomnographic study. And we hope that this system can help people to sleep well.